All right, guys, here are the solutions to homework number 4, solving systems by the elimination method. Check it out. All right, just 6 problems to go over. Here we go. Problem number 1. The thing I noticed about problem number 1 is that the x's are already opposites of each other. So I can just go ahead and add the equations together and the x's will cancel out. The negative 6x and the positive 6x, see ya. 4y and 10y is 14y, and 28 plus 28 is 56. Now that I've canceled out the x, it is easy to solve for the y. I would simply divide both sides by 14, and I would end up with y equals 4. And I now have half of my ordered pair that is the solution to the system. To get the other half, I take one of the equations. I'm going to take this one, 6x plus 10y equals 28, and I substitute my answer in place of the y. So instead of 10 times y, 10 times 4. Oops. And so that would be 6x plus 40 equals 28. And if I subtract 40 from both sides, I end up with 6x equals negative 12. And then if I divide by 6, I end up with x equals negative 2. And I've got my answer. Problem 2. Problem 2, I noticed that neither the m's or the n's are opposites of each other. So I'm going to have to multiply by something. I think the easiest thing would be to get rid of the m's, right? Because the m's are already the same number. I just need to make one of them opposite. So I am only going to need to multiply by negative 1 so that I turn a 5 into a negative 5. I will go ahead and multiply the first equation by negative 1, and I will leave the second equation as is. So when I multiply the first equation by negative 1, it becomes negative 5m, and the positive 3 would become negative 3n, and the positive 24 would become negative 24. The second equation stays the same, and now I have my new system, and now I'm ready to add the equations together. The negative 5m and the positive 5m, when you add those together you get 0, or they just cancel out. The negative 3n and the positive 8n would be positive 5n. And negative 24 plus 39 is 15. I can then go ahead and solve for n by dividing both sides by 5. And I get n equals 3. So I now have half of my answer. Notice I'm not going to write this one as an ordered pair since it's not x and y, although I could write it as an ordered pair, and it would come in alphabetical order, mn. I now am going to take my answer for n and put it into one of the equations. I'm going to go ahead and use this equation, and I'm going to put the 3 that I got for the answer in place of the n. So instead of 3 times n here, it's going to be 3 times 3 equals 24. Solving that, I would get 5m plus 9 equals 24. I would subtract 9 from both sides and get 5m equals 15. I would divide both sides by 5 and get m equals 3. And so I have my solution for this system m equals 3 and n equals 3. The next problem. Again, neither the x's or the y's are opposites of each other, so I need to multiply by something to get one of them to cancel out. I am going to go ahead and cancel out the y's. To me, they just look easier. Right now, I have a 1 and a 5, and I would like them to be the same number. So it seems easy enough that I could multiply the 1 times 5, and then they would both be 5s. And that seems like the plan I'm going to go with. So I'm going to multiply the top equation by 5, and I'm going to leave the bottom equation again as is. When I multiply the top equation by 5, 5 times 4x gives me 20x. 5 times negative 1 gives me negative 5y. And 5 times 12 gives me 60. The bottom equation is just staying the same. And you will now notice the y's have become opposites of each other. So when I add these equations together, the y's are going to cancel out. 20x plus 5x is 25x. 60 plus 40 is 100. And I have added the equations together and eliminated one of the variables. I can now go ahead and solve for x by dividing both sides by 25. And I get x equals 4. And I now have half of my solution. I now need to take my solution and substitute it back into one of the equations. I guess I'm going to go ahead and use this equation just because I don't want to deal with the negative. So this would be, instead of 5 times x, it would be 5 times 4 plus 5y equals 40. Solving that, I get 20 plus 5y equals 40. I subtract 20 from both sides and get 5y equals 20. And finally, I divide by 5, and I get y equals 4. So, I now have my ordered pair, x equals 4 and y equals 4. Last equation today. I notice on this one, well, it's not the last one, I don't know what I'm saying. The m's are already opposites of each other. Nice. So I can just go ahead and add these equations together and the m's will cancel out. Positive 1n and negative 3 would be negative 2n. 9 and negative 21 would be 12 negative 12. Now that I've canceled out one of the variables, I can easily solve for the other one by dividing both sides by negative 2. And I get negative 12 divided by negative 2 is a positive 6. So I now have half of my answer. I get the other half by taking that and putting it back into one of the original equations. I'm going to go ahead and put it in this equation. So I would have 2m, but instead of plus n, I'm going to put the 6 in for the n and go plus 6 equals 9. And to solve that, I would subtract 6 from both sides, giving me 2m equals 3. I would divide both sides by 2, and I would get m equals 3 over 2, or 1.5, or 1.5. Any way you write it is fine. M equals 1.5, n equals 6. We go to number 5. Number 5 does not have opposites. So, since 5 and 2 don't go into each other, I think I will go with the y's here. to make my opposites because I know that 2 can be multiplied by something to equal 10. So it looks like I'll just be multiplying the first equation. Well, I'll be making the y values both become 10. The second one is already negative 10, so I'm going to leave it alone. The first one, I want it to become a positive 10, so I need to multiply by 5. When I multiply the first term by 5, I get 25x. The second term gives me positive 10y, and 5 times negative 19 is negative 95. And like I said, the second equation, I'm just leaving it as is. And I'm ready to go ahead and add my equations together because the y's are now opposites of each other. When I add these together, I get 27x equals negative 95, and 14 is negative 81. Now that I have eliminated one of the variables, I can easily solve by dividing both sides by 27, leaving me with x equals negative 3. So now I have half of my ordered pair. To get the other half, I go ahead and take what x equals and I substitute it back into one of the equations. I'm going to use the first one. So instead of writing 5 times x, I'm going to do 5 times negative 3. Plus, is that a plus? It is a plus. Plus 2y equals negative 19. Oops. So that would be negative 15 plus 2y equals negative 19. I can solve that by adding 15 to both sides, giving me 2y equals negative 4, dividing by 2, and I end up with y equals negative 2. And I have now solved that system. Last up, problem 6. In problem 6, let's see. I guess I'm going to go ahead and cancel out the g's. I would be multiplying the top equation by 3 so that I end up with a 6 here and a 6 here, right? But I want one of them to be positive and one of them to be negative. Since this one's already a positive 6, I'll just go ahead and leave it alone. And I'll turn this one into a negative 6 by multiplying by negative 3. And that would give me, let's see, negative 3 times that gives me negative 6. Negative 3 times that gives me negative 9. And negative 3 times that gives me negative 27. Now that I have my opposites, I'm ready to go ahead and add the equations together. Negative 6 and positive 6 cancels out. Negative 9 and positive 9 cancels out. Well, that's interesting. Both things canceled out. So on the left side of the equal sign, the whole thing just equals 0. Normally I don't put the 0 in, but since there's nothing left there, I do need to fill in the 0. I can't just leave it blank. And on the right side I have negative 15. So this brings me to an issue. I can't solve for a variable because there's no variable left in the problem. This tells me one of two things. It either tells me that there is no solution because the variable's canceled out, or it tells me that there is infinitely many solutions because the variable's canceled out. The only question left is, how do I know which one? What does this tell me? Does this tell me that there's no solution, or does this tell me that there's infinitely many solutions? So let me tell you that there is no solution when the variables cancel out and you are left with something that is false. There is infinitely many solutions when the variables cancel out and you are left with something that is true. So if I was left with something like 0 equals 0 or 7 equals 7, that would tell me infinitely many solutions. But in this case, I was left with something that is false. I was left with 0 equals negative 15, which is false. That tells me no solution. The answer is no solution. All right, hope that helps. Good luck.